Hey y'all, this is the video for lesson 2.4, which is all about atoms, atomic mass, things of that nature. So let's just dive on into that. So as you are looking at the periodic table, you get a lot of different information. It might not look like it, but this is a lot of different information. So as we're looking at that, it does tell us how to find the number of protons, which is actually equal to the atomic number, which is usually found somewhere at the top. Sometimes it's on the left, on the right. This one happens to be in the middle. The one on your notes, I think, is on the left. I don't remember. The periodic table in the back, it is on the right-hand side as you're looking at it. But that atomic number is equal to the number of protons in an atom of, for this example, oxygen, has 8 protons. Most of the time, it is also equal to the number of electrons. The atom needs to be neutral for that to happen, and we'll talk about in the next unit when that is not true, when the atom is not neutral, how to figure that out. But for right now, it's good enough to know that the atomic number here also tells us the number of electrons in an atom. Again, with oxygen, that happens to be 8. Lastly, to find the number of neutrons, basically what you do is you take the atomic mass and you subtract the atomic number. So the atomic mass is neutrons plus protons. It's what gives the atom most of its weight, most of its mass. So neutrons plus protons. So in order to find neutrons, all you have to do is take that number minus the atomic number. If you'll notice on the example in your notes and also in the periodic table in the back, frequently that number is, like yours should say 15.9994, something like that. Basically, you round that to the nearest whole number in order to subtract. And we will talk later on in this unit when we talk about isotopes why that's not a whole number. Why it's not a counting number when we're talking about protons and neutrons, and you should just be able to count them. But that's a little too much for right now. So just round to the nearest whole number and then subtract. So for this one, 16 minus 8 means there's also 8 neutrons in an atom of oxygen. So let's do a quick example. Let me move my face over here. So quick example. Sorry, this is kind of blurry. And I will say on your notes there's a mistake. We'll get to that in a minute. But for this atom right here, the total number of protons, again, we can just count them at this point. 1, 2, 3, 4, 5. We get 5. The number of electrons, we shouldn't need to count them. 1, 2, 3, 4, 5. But we do. Since it's neutral, there are also 5 electrons. There are supposed to be 6 neutrons. So I know on your picture, let me get a pen here. On your picture, it says plus and then it has blank ones, right? So the pluses are obviously protons. Draw an extra circle. So there are 6 neutrons. So please do that. If I click, does that go on? No. Dang it. Okay. There. 6 neutrons. All right, back to my pen. So the little periodic table symbol for this would look like there would be a 5 at the top. There would be the symbol for the element. I'm going to put a poor question mark right there because of what is coming up. And then along the bottom would be the atomic mass, which at this point we can just write down as 11. We'll just say 0.00. So for this atom right here, the atomic number, which is the number of protons, is the number at the top, right? So this is the periodic table square, right? The atomic mass is 11, 5 plus 6, protons plus neutrons. Please make sure you've drawn that extra circle in there. And then as far as the symbol, I want you all to tell me what that is. So what element is this based on knowing how many protons and neutrons it has? Email me your answer, and I will give you some extra credit.